Okay, chapter 3, matter. It always makes me think, what's the matter? Yes, bless you, someone's sneezing. Okay, so this chapter, some of you will be relieved to find that there's very little math in this chapter, so you'll like that. Yeah, thank you. So we have to first define what we mean by the word matter in chemistry, and we mean anything occupying space and having mass. Okay, so that includes a lot of things, doesn't it? Matter exists in 3 common states: solids, liquids, and gases. And you need to know what those states are: solids, liquids, and gases. And here we have an illustration showing the 3 states of water. Water is good to look at because it's one of the few substances that we have personal experience with all 3 states. Okay, in the solid state we call it ice, in the liquid state we call it water, and in the gas state we call it steam. So there's different characteristics of these different states, and it has to do with how the particles are interacting. So in the solid state, the particles are close together. Some books say they're touchingly close, but they're held in a fixed position. They can't move about. In the liquid state, they are still close together, but now they can mingle and move around. And in the gas state, the particles are very far apart, and they don't interact at all, and they're free to move completely independently of each other. So I have an analogy for the 3 states of matter. You'll find I have a lot of really stupid analogies, right? But then the stupider they are, the more likely you are to remember. So I'm trying to make them stupid. Yeah. So 3 states of students. Okay, currently in this classroom, the students are in the solid state. Okay, so you're sitting in the same positions relative to each other. Cody and Amy are always in this same relative position while you're all sitting at your benches. Now, are you all sitting absolutely still? No. You're looking around, there's people walking outside, you're scratching your ear, you're hopefully taking some notes, you're breathing. Yeah, keep breathing. You're all moving, right? Particles in the solid state are not stationary, they're moving, but they don't move relative to the other particles. Okay? The liquid state of students is like what we have during lab. We're all still pretty close together, we're all in this little room together, but now we're moving around. Okay, and I'm going to pick on these guys because I remember their names, and they're close to me. And so, Cody might walk over there, and Amy might go over there, and we're moving around. Okay, so we're moving more, but the important thing is we're moving relative to each other. In the liquid state, the particles can move about like that. They're still going to stay in a small area, small volume, but they're going to move around. The gas state of students, we don't have a bell here, but when it's time and we leave, the gas state of students is when you guys go out the door. And you guys go off in all different directions, right? We just spread out, and we may not see each other until we come back to the solid state on Wednesday for lecture, right? And so we're far apart from each other, we're moving independently. So that's your picture for how the states of matter are. So then we'll have some slides here that give us something to write down. So solids are rigid. They have a fixed volume and a fixed shape. You think of an ice cube. Okay? The ice cube, you move it from its tray to a bowl. Does it change its shape? Nope, it stays ice cube shaped. Does it change its volume? Nope, the volume stays the same. Solids retain their shape and their volume. Examples of solids: ice cubes, diamonds, an iron bar. Lots of things are solids. My mouse is a solid, my phone is a solid, my sunglasses, lots of solids. Liquids. Liquids have definite volume, but no specific shape. If you take a cup of water and pour it from a tall, skinny glass into a short, shallow bowl, it's going to change its shape. Does its volume change? No. It still has the same volume. It's still 1 cup of water, regardless of what shape it's in. So solids and liquids both keep the same volume. They have a fixed volume. But liquids can change shapes, and solids do not. So we say that liquids assume the shape of the container, whatever they're in, they take on that shape. Examples, gasoline, water, alcohol, blood, these are all liquids. Here's a picture showing how, here's colored water taking on the shape of its container. And this one probably reminds you of those curly straws that were just, so fun to use when you were a kid, right? And your mom throws it away as soon as she can because it's impossible to clean and it's just full of bacteria. Personal experience there. We don't have any of those anymore. Okay, gases. Gases have no fixed volume and no fixed shape. They change their shape and they change their volume. They will take on the shape and the volume of the container. A gas will expand to fill the container that it's in. No matter how big it is, the gas will just keep getting bigger and bigger. Or if you make the container smaller, the particles will just get closer together and they will still fit in there. And so that's something that's unique about gases. Examples of gases: air, helium, oxygen,